Welcome everyone in lecture number 7 of Laplace transform. Here in this lecture we will learn the Laplace transform of derivative. That means how to find the Laplace transform of a derivative of the given function. So let me first define the rule to find the Laplace transform of derivative of the function. So let we have ft and f dash t. F dash t means derivative of this function ft be the functions of class A. You know the meaning of class A means both of these functions are piecewise continuous as well as of exponential order. This property makes sure that the Laplace transform of these two functions will exist. So if these two functions are of class A, then Laplace transform of derivative of the function ft, that is f dash t, is defined as p into Laplace of ft minus the value of the function at 0, where p should be greater than sigma, where sigma is the order of exponential of the function ft. So Laplace transform of first derivative, you mean what is the meaning of f dash t? It is the first derivative of the function ft, that is d over dt of ft. तो इस फंक्शन का डेरिवेटिव हमने कैसे डिफाइन किया गया है? p इंटू लाप्लास ऑफ एफ टी माइनस एफ एट 0. Similarly, if we have second derivative of the function, then we can also find the Laplace transform of second derivative of the function. For that, we again assume that ft f dash t, this is the first derivative, and of course f double dash t be the functions of class A. So Laplace transform of these three functions will definitely exist because these are of class A. So we can define the Laplace transform of f double dash t, which is the second derivative of the function ft, defined as p square into Laplace of ft minus p into f at 0 minus f dash at 0. Because ft belongs to class A, so L of ft will exist, and here these two are the values of the function at 0. So you can learn the pattern here. Here when we have first derivative, we have first power of p, and then power of p will keep on decreasing in the next step with negative sign. Here also we have second derivative, then we have second power of p, that is p square, then first power of p, that is p, and then p raised to the power 0 here. And in general, we can define the Laplace transform of nth derivative of the function in the same way by assuming that ft, f dash t, f double dash t, and f and t are all belongs to class A. In that case, we can define the Laplace transform of f and t means the nth derivative of the function ft. It is defined as p raised to the power n Laplace of ft. You can guess what will be the next step. Of course, next step is p raised to the power n minus 1, then f at 0. Again, in the next step, the power of p will get decreased by 1, and we have f dash at 0. And in the last, we will get, what is the last term? You can see here, when it is first derivative, we have 0th derivative. When it is second derivative, we have first derivative. When it is nth derivative, then we have n minus 1th derivative at 0. So this is how we define the Laplace transform of derivative of the given function. So if you are interested in the derivation of these formulas, you can go through the well-known books of Laplace transform. Here we have, there is the detail of the derivation of these formulas. So to understand the significance of these formulas, let us do one example quickly. So let me take a very simple example for you. Example number 1. Example is, if Laplace transform of 2 square root of t over pi is 1 upon p raised to the power 3 upon 2, then show that one upon p raised to the power half is equal to Laplace transform of 1 upon square root of pi into t. You may have one question in your mind, that how do we know that we have to use a formula for Laplace transform of derivatives here? The answer is that you are given the Laplace transform of this function, and you are asked to prove the Laplace transform of this function. So you can do some rough work and check whether this function is the derivative of this function or not, if you leave some constant terms which are appearing. So you can try in a rough sheet that whether this function whose Laplace transform is asked to you is the derivative of this function or not. If it is, then it is very clear that you have to use the Laplace transform of derivative of the function's property. So obviously, what will be the function here? The function is 2 square root t upon pi. This is our original function, and this is the derivative of this function. So first of all, we state what will be the function. So we state here that function that we take here is 2 square root t upon pi. ये हमारा फंक्शन है, ये हम इस क्वेश्चन में डील करेंगे ft. Now you can see that the value of f dash t is 2 into 1 upon 2 into t raised to the power minus half whole divided by square root of pi. Because of here we have positive half power. When you subtract 1 from that, you will get minus half. So it is 1 upon square root of t into pi. Exactly what is given here is the derivative of this function. So ये आपको पहले शो करना पड़ेगा क्वेश्चन में. सॉल्यूशन में जब आप करेंगे इस क्वेश्चन का सॉल्यूशन, तो आपको ये पहले क्लियरली स्टेट करना होगा दैट व्हाट इज एफ टी एंड व्हाट इज एफ डैश टी हियर. So f dash t here is the derivative of this function, which is this value. So you are asked the Laplace transform of derivative of the function ft. So this is original ft and this is the derivative of ft. So now we write here Laplace transform of f dash t, which is nothing but Laplace transform of 1 upon square root of t into pi, is defined as into Laplace of ft minus f at 0. So here you put the value that is given to you in this question. This value 1 upon p raised to the power 3 upon 2. This is Laplace of ft here. So we put here 1 upon p raised to the power 3 upon 2 minus the value of f at 0 is 0. So it is 1 upon p raised to the power 1 upon 2. Hence proved. Very simple to understand. Let us take one more example. If Laplace of sine of square root of t is square root pi over 2p raised to the power 3 upon 2 into e raised to the power minus 1 upon 4p, then show that Laplace transform of cos of square root t over square root of t is square root of pi over p multiplied by e raised to the power minus 1 upon 4p. Again, you can do some rough work and check that whether this value is derivative of this function or not. So I will do it fairly for you. So I take my function ft as sine of square root t. Then I will find the derivative of this function without bothering what is given here. The derivative of this function is cos of square root t, and then the derivative of square root of t is 1 upon 2 square root t. So it is 1 upon 2 cos square root of t over square root of t. This term is extra here. So nothing to worry about this. Whenever some constant term is appearing in the derivative, you can separate that constant term by linearity property of the Laplace transform. So we move ahead. So we directly apply the formula of Laplace transform of derivative of the function is defined as p into Laplace of ft minus f at 0. Now we put here the value of f dash t, that is obtained as 1 upon 2 cos of square root of t upon square root of t. Put exactly what you are getting in the derivative. ओके आपको एक्चुअल वैल्यू ही रखनी है जो एफ डैश टी की आ रही है and then put the value of Laplace of ft. This is ft and Laplace of ft is this expression. So let me substitute it for you. Square root of pi over 2p raised to the power 3 upon 2 into e raised to the power minus 1 upon 4p. Minus f at 0 is again 0. So it is square root of pi over 2 square root of p e raised to the power minus 1 upon 4p. This is what we are getting the value of Laplace transform of 1 upon 2 cos of square root of t over square root of t. But we are asked the Laplace transform of only this, not this. So by linearity property, we can separate this 1 upon 2 from Laplace transform just simplify it. This 2 will cancel with this 2 and hence the result. यही हमें प्रूफ करना था. So this proves that the Laplace transform of cos square root of t over square root of t is this. So you can understand the significance of this property of Laplace transform, which gives you the the Laplace transform of derivative of the given function. So if you are given the Laplace transform of some function and you are asked the Laplace transform of some other function, then you can check whether this function is the derivative of this function or not. Then you can apply this property directly. Maybe sometimes, like in the second example, you will not get the derivative of the function exactly what is given in the question. You may get some constant terms along with this also, but you can separate those constant terms like this by linearity property and then you can use the result. I hope you understand this property clearly, and if you like my lecture, please press the like button and share my lecture also, and you can subscribe my channel to get the notification about new videos or new lectures on this topic. Thank you very much.